presentation today of Fabian Hosp from PreOmics, and he's going to talk about efficient sample preparation for proteomics.
Yeah, thank you very much for the introduction and for the opportunity to speak here. So, just going to share my screen. Okay, so yeah, we at PreOmics, we're focusing on sample preparation tools for mass spectrometry-based protein analyses, and basically our technology is based on the original in-stage step technology, short IST publication that was published in Nature Methods, now has more than 800 citations. And since 2014, we have further optimized and developed this technology. We have commercialized it into kits, which are available, providing this streamlined three-step workflow, where we have basically a 10-minute lyse step to lyse cells, denature proteins, reduce and alkylate them, followed by a 1-hour digestion using both lyse and trypsin, and a final 1 hour.
Sorry to interrupt you. Sorry to interrupt. You're not sharing yet the screen, just to let you know.
Oh, sorry.
No, no problem.
I thought I pressed on it. Is it on now?
Yes.
Okay, perfect. Sorry for that. Yeah, so again, here on the top left, you can see the three-step workflow with the 3 steps. So we have the lyse, digest, and purification step. And as said, we have further developed this. We have optimized it to be compatible with chemical labeling workflows, for instance. We have further enhanced the robustness, and we also made it compatible to many different types of samples, including different kinds of cells, body fluids, tissue samples, several intact model organisms like bacteria, yeast, or algae, or even more protein-related samples such as IPs or monoclonal antibodies. And I just want to highlight 2 more recent publications using our IST workflows. So here on the left, you can see a publication from Sophia Doll et al. From Matthias Mann's lab, reporting the deepest human heart proteome using IST. And on the right, you see a very recent publication from Bailin Zaro et al. From Irving Weissman's lab at Stanford, reporting differential protein expression in aged and adult hematopoiesis in mouse stem cells using only 1 microgram of protein input material. So the technology is easy to use and can be applied to many different sample types. And in the next slides, I just want to give an update on new developments from our side. So over the last year, we have introduced our automation platform, the PreOn, that can process up to 12 samples in parallel and can do that both in a label-free fashion or even for chemical labeling workflows. So if you do any kind of TMT experiments, for instance, it also provides extremely minimal hands-on time. So basically, you only have to select certain predefined workflows. It takes about 5 minutes, place our buffers and the samples, and then all the rest, the lysis, digestion, and peptide cleanup is fully automated. And since it's a robotic platform, so it's more precise and accurate in liquid handling and overall sample processing, we do see significantly improved technical variability and quantitative reproducibility comparing it to our own manual workflows. And this is basically what you can see here on the bottom. So on the left, you see in the box plot the CVs for processing human serum, so either 10 or 100 microgram of protein input material. And you can see that for the automated processing, for the blue bars, you see better CVs than for the manual processing. And similarly, if we look at the quantitative reproducibility, we do see better Pearson correlations when processing 10 microgram of human serum, again, for the automated fashion in the lower blue plots compared to the manual fashion in the green plots on the top. Next, we have now developed a new workflow specifically for cysteine-rich samples, such as certain body fluids or biopharmaceutically relevant proteins, such as therapeutic proteins or monoclonal antibodies. And what you can see here in this plot is basically a comparison between our regular IST workflow and the newly developed IST-BCT, so that stands for biopharmaceuticals, where we do observe increased number of cysteine identifications and higher alkylation rates, That's plots C and D. And at the same time, we do see reduced artificial modifications such as methionine oxidation and deamidation, which is particularly important when processing therapeutic proteins or monoclonal antibodies in regulated environments. And finally, we have also developed a completely new tip-based peptide fractionation, so employing a three-step peptide fractionation directly from our cartridges, or our SPE material that are provided. And we do see an increase of about 200% in protein IDs and 300% in peptide IDs when comparing our three-step fractionation to our regular IST workflow. And so this three-step fractionation provides an appealing trade-off for significantly increased identification rates with a modest increase in measuring time. So thank you very much for attending the talk, and I'm happy to take any questions.
Let me see here. Oh. Sorry, can you hear me?
Yes.
Yeah, here we go. Sorry, they're controlling my mic and everything. So, yes, so thank you, Fabian, for a very nice presentation. So, I might have missed it here. When you talked about this, you can process 12 samples in parallel with this device?
Yes.
And what is the amount of time it takes to process those through the?
So in a label-free workflow, it takes about 2.5 hours, and for TMT labeling, it takes 3.5 hours because the TMT labeling is then 1 hour extra. I
see. Okay, thank you. Okay, well, I don't think there's any questions from the audience. So thank you very much, Fabian, again, for your presentation and your participation in US HUPO.
Thank you very much.
So thank you very much, everybody. I'm very pleased